Imagine walking into a 400 or 500-year-old city where almost every house has its own bathroom, a drain in the floor, and access to clean water, while much later medieval towns in Europe were still throwing waste out of upper windows into the street. That is the world of Mohenjo Daro, one of the largest cities of the Indus Valley civilization, and the place many archaeologists point to when they talk about the first true urban drainage system in history. In this video, we are not just name-dropping a famous ruin, we are unpacking how Mohenjo Daro engineered plumbing and drainage on a citywide scale, and what the archaeology actually shows about how this ancient sanitation system worked day to day. Mohenjo Daro sits in today's Pakistan, on a plain that floods easily when the Indus River and the summer monsoon rains swell. Building a big Bronze Age city there was asking for trouble. Stagnant water, sewage in the streets, mosquitoes, disease. Yet the Harappan engineers who designed this city turned water from a threat into an infrastructure project. They laid out the streets in a grid that followed the natural slope of the ground, and then built the drainage network and building levels around that invisible spine. When people search for Mohenjo Daro plumbing, what they are really asking is, did these ancient builders just improvise drains? Or did they think like modern urban planners? The evidence from excavations says the second option. Archaeologists digging at Mohenjo Daro and other Harappan cities have found a striking pattern: standardized baked brick houses, many of them 2 or even 3 stories high, each tied into an urban web of water supply and waste removal. At the level of the individual house, the system started with water. Mohenjo Daro had more than 700 wells packed into a relatively small urban area. Many houses had a private well inside a small courtyard, so a family did not depend entirely on public sources. From that courtyard, a narrow doorway often leads into a small bathing room, a brick-paved floor raised slightly above the rest of the house, carefully sloped toward one corner. In that corner sits a drain opening built from fitted bricks or terracotta segments, the entry point to the hidden infrastructure. A person would wash using water drawn from the well. The dirty water ran across the sloped floor into the corner drain, then flowed into a short horizontal channel built inside the wall. From there, it dropped into a vertical chute or pipe that emptied into a covered drain along the street outside. In some houses, archaeologists have found small toilet cubicles built against the outer wall, with a simple seat or platform above a vertical shaft. The user would pour water down after themselves, flushing waste into the same brick-lined drains. It is not a modern flush toilet, but as ancient urban sanitation systems go, this is remarkably sophisticated. At the scale of the street, the Harappan engineers treated wastewater as a city-level design problem, not just a household inconvenience. Along the main streets of Mohenjo Daro, they laid continuous brick-lined drains, usually covered with stone or baked brick slabs, so that people and carts could pass over them. These drains were not random trenches. They were built with controlled gradients so that water actually moved instead of stagnating. At regular intervals, the covers have inspection holes or removable sections, the Bronze Age equivalent of a manhole cover, allowing workers to reach in and clear blockages. Short branch drains from individual houses and side lanes feed into these larger channels, creating a tree-like pattern of collection. In some sectors of the city, the street drains then empty into larger soak pits or cesspools outside the built-up area, where solids could settle and the liquid gradually seep away, instead of backing up into the neighborhood. One modern description of the system talks about tunnels under Mohenjo Daro, carrying waste toward low-lying ground near an ancient estuary, reminding us that even without huge masonry sewers like those in later Rome, the principle of moving waste away from where people live was already in play. All of this depended on a small set of technologies that the Indus Valley civilization had mastered. Standardized bricks, in a typical ratio of about 4x2x1, made it possible to build straight, smooth channels where joints line up and can be sealed. In the Great Bath, the famous public pool on the Citadel mound builders used bitumen to waterproof the brick structure, showing that they understood how to keep water in when they wanted a reservoir, as well as how to keep it out of the walls of their buildings. Terracotta pipes and chutes carried water down from the roofs and upper floors into the street drains. So the system did not just handle bathroom wastewater, it helped manage rainfall as well. When you look at this package together, wells, bathing platforms, private toilets, covered street drains, soak pits, you are not just looking at a neat trick of Harappan engineering, you are looking at a coherent piece of ancient urban planning. Indus Valley archaeology over the last century has reinforced this picture. Excavators in different sectors of Mohenjo Daro, working years apart, have uncovered the same repeating pattern, house after house, fronting onto narrow lanes, almost all of them with some provision for washing and some connection to a drain. There is variation, of course. Richer houses have larger bathrooms or more than one, and some small dwellings lean on public infrastructure more heavily, but the baseline level of service is high. Unlike many ancient cities where only palaces and elite compounds enjoyed piped water or drainage, here ordinary residents in modest brick houses are plugged into the system. That has led some historians to argue that public health and everyday convenience were not afterthoughts. They were built into the way Harappan cities were conceived. It is also striking what we do not find. Mohenjo Daro does not have towering stone temples or royal statues covered in boasting inscriptions. Instead, the big features that dominate the site are things like the Great Bath, large granary-like structures, and the massive platforms that seem designed to lift parts of the city above flood level. In other words, the most visible investments of labor went into storage, water management, and flood control. When people talk about Bronze Age engineering, they often jump to weapons or palaces. Mohenjo Daro pushes us to widen that picture. Here, engineering shows up in the quiet, routine business of keeping streets dry and waste out of people's living space. Of course, there are limits to what we can reconstruct. The script of the Indus Valley remains undeciphered, so we have no ancient manuals explaining how often drains were cleaned or who paid for repairs. Some scholars debate exactly how far the network extended or whether there were true trunk sewers collecting all the flow. What we can see in the ground, though, is enough to say that this was not a token effort. When maintenance began to slip in the later phases of occupation, drains were reused, narrowed, or blocked, and houses crowded into older open spaces. Archaeologists can literally see sanitation standards declining in the soil layers. Climate studies suggest that shifts in the monsoon and periods of drought gradually undermined agriculture across the region, contributing to the dispersal of Harappan cities. Mohenjo Daro's drainage system could manage seasonal floods and everyday waste. But even the best engineered pipes and channels could not hold back an unstable river system. Still, the fact that this city functioned as well as it did for centuries tells us something important about how early urban societies thought about risk and resilience. When you compare Mohenjo Daro drainage to what came much later in many other parts of the world, it starts to look less like a primitive first attempt and more like an early peak in urban sanitation design. If you live in a modern city with buried sewers, storm drains, and building codes that require bathrooms to connect to them, you are living with the same basic logic that Harappan engineers built into brick and terracotta. The details have changed, the materials have evolved, and we now simulate fluid dynamics with computers instead of eyeballing gradients in the field, but the core idea is the same. Control water, move waste safely, and design the city so that everyday habits, washing, cooking, flushing, feed into that system automatically. As researchers dig deeper into Mohenjo Daro excavation records and refine our picture of Indus Valley plumbing technology, we are not just learning trivia about a lost world. We are tracing the deep history of something we take for granted every time we turn on a tap or step into a shower. So as you watch the rest of this video, keep an eye on the unglamorous details in the reconstructions. And site photographs, the brick channels at street corners, the little holes in the covers, the battered wells and house courtyards. Because that is where the story of how this ancient city engineered the first urban drainage system really unfolds.